Objective of this experiment is to determine the grating constant of the given grating plate and mean wavelength of a given semiconductor laser using diffraction by calculating the grating constant. Formula to find the grating constant and the wavelength are as shown. Here, capital N represents the number of lines per inch on the grating plate. Theta is the angle between 0th and nth order spot in a diffraction pattern, where small n is the order of the diffraction pattern. Diagram is as shown. Here, the laser light will come out of the laser source and incident normally on the grating plate, and it get diffracted. The diffraction pattern is caught on the screen. The distance between the screen and the diffraction grating is kept as 1 meter. As we have mentioned, theta is the distance between the nth order and the 0th order of the diffraction pattern. Apparatus required: laser, diffraction grating or grating plate, long scale, screen or graph. Screen is placed 1 meter away from the diffraction grating, and laser is adjusted in such a way that it will make a normal incidence on the grating plate. After getting diffracted, the image or the diffraction pattern is caught on the screen. It is as shown. The center bright spot is called 0th order or center maxima. The bright spot on either side of the 0th order is called first order or first maxima. The second bright spot on either side of the 0th order is called second order or second maxima. Similarly, the third bright spot on either side, we call it as a third maxima or third order. As we have mentioned, we need to calculate the distance between the 0th order and the nth order. This is how we will be calculating the distance between the 0th order and the nth order on the either side of the center maxima or the 0th order. We will be calculating the distance between the nth order on either side with respect to the center maxima. Here we have calculated the first order. For the first order, the distance is 1.3 centimeter. For the second order, it is 2.6 centimeter, and the readings are tabulated. Tabulation is as shown. Here, y is the distance between the center maxima and the nth maxima on either side of the center maxima or 0th order, where x is the distance between the screen and the grating plate, and that is, we have fixed it, that is equal to 1 meter. By substituting the value of y and x, we are able to calculate the angle. By making use of this angle, we will be calculating the wavelength as shown. The grating constant is given by 1 divided by capital N, where 1 is in inch, N is the number of lines drawn per inch on a grating plate. By substituting the values for inch and N, we are able to calculate the diffraction grating constant or grating constant simply, that is equal to 5.08 into 10 power minus 5 meter. By substituting the value of sin theta and grating constant and the order of diffraction, you can calculate the wavelength. Here we have calculated for the first order of the diffraction pattern, that is equal to 660.34 into 10 power minus 9 meter. Outcome of this experiment is we were able to calculate the grating constant of a given grating plate, that is equal to 5.08 into 10 power minus 5 meter. Then we are able to calculate the mean wavelength of a given semiconductor laser, that is given by lambda, that is equal to 660.13 into 10 power minus 9 meter.